Greetings folks and welcome to the Electromaker Show. This is your roundup of all things maker and embedded and lovely. And this week is a very special show because we have a short interview with Kevin Cappucio, who is the creator of Jumperless. Now, the original Jumperless project is one we talked about on the Electromaker Show. In short, it is a fully automated breadboard, which means you do not have to use any jumper cables to connect your components together, and you do not need to use a separate probe to probe parts of the board. The new version does come with a probe, but it does quite a lot of separate things as well. And the Jumperless version 5, which goes live on Crowd Supply today, is a significant upgrade over the original for various reasons, which I will let Kevin go into himself. We'll also be announcing the winner of our Texas Instruments giveaway that we've had running for the last couple of weeks, and we'll be starting a new Product of the Week giveaway. Yes, our Product of the Week this time is the Arduino Alvik, their all-in-one STEM learning kit for robotics, and we'll be talking about that too. But that's not all. We are going to be covering Bitluni's amazing new LED magnet thing that he's put together on his YouTube channel and the tech behind it. I went down a bit of a rabbit hole, and various other things. So before this introduction becomes massive, let's get on with the show. We're going to begin this week's show by talking about Bitluni, who's someone who I have been watching for a very long time. His channel is amazing. If you've never caught one of his streams, they're wonderful as well, because it's just him right down at the metal trying to make things work, and often they don't. And his approach to problem solving is quite inspiring. Anyway, the particular video in question is developing a high-fidelity LED magnet matrix. The basic idea behind this is he bought a box of LED matrices years ago and felt guilty for not using them, so has come up with this amazing plan to put it together. Now, surprise, surprise, he uses one of the new RISC-V parts, the CH32V203 or something along those lines. I have actually forgotten. 208, there we go. And he has made this incredible thing that you can attach together with different magnets, and it looks really quite beautiful, and you can get it to do all kinds of different things. Now, the video itself is absolutely worth going and watching, and as with everything I ever talk about on the Electromaker Show, I want you to go and watch the source content more than hear me talk about it, really, because ultimately it's the thing that made me enthusiastic to talk about it. However, this time I do have a little more to say, because the weird rabbit hole that I fell into after seeing a certain part of this video, which is how he planned to actually address all of the LEDs with a high frame rate, really got me thinking. So I watched the video and saw the part about binary code modulation, which is a different way of approaching LED dimming, and then sort of forgot about it. But just a couple of days later, there was this article by Julian Sheffers on the Hackaday front page. As you can probably tell by the content of the show, I'm an avid Hackaday reader. I really do love this site. But in the comment section, it mentioned the way that he dims the LEDs is worth checking out. I was like, oh yeah, that was kind of interesting. Which links out to yet another Hackaday article, which in itself links out to the most 1990s website I've ever seen. I absolutely love this. This is text on a page. The internet, folks. Every website that I've ever made looks like this as well, actually, which is why I don't have a website anymore. I don't know what I'd put on it. Anyway, in short, this is just a really nice step-by-step guide through PWM and why you might want to use binary code modulation instead. I'm assuming most folks watching the show will have a rough idea what PWM is already. If not, this will give you a really good guide to it. I can give you a really rubbish guide right now, which is if you turn your GPIO pin that the LED connected to is on, that LED will be on, as bright as it can be. If you very quickly turn that pin on and off, so it's on and off the same amount of time, the LED will appear half as bright. Ish. I don't actually know if it's linear like that. It might be logarithmic. Things are weird when it comes to stuff like that. But the amount of time you have the LED turned on versus off is how dim it can be. Binary code modulation allows you to not have to worry about every single moment the GPIO pin is running. You don't have to come up with a command of high or low. You can just set it bitwise. So if you're going here from the least significant to the most significant bit, let's just say, oh yeah, this is perfect actually. If we have a 4-bit code, the bottom bit represents 1, the next bit is 2, 4, 8, and this is, 1, 2, 4, 8. This is 4 bits. By having those 4 bits set up 1, 1, 0, 1, you end up with 1, 0, 4, and 8. If you graph that, you have 1 on, and then bit 2 is off, but this is actually 2 different steps. It's twice the size of bit 1, so you get twice the amount of time off, and then doubled again to the 4, but this is on, and then doubled again to the 8, so this is also on. Maybe you can already see that this is very powerful by using different combinations and different amounts of bits that you're pushing into it. I think Bitluni ended up using 12 bits, so he has a much higher resolution, but that will allow you to have varying different degrees of PWM, varying different degrees of brightness without using PWM. And of course, if you have any moment where one of these really wide bits is set on or off against the timing, that's timing that your microcontroller could be using to do something completely different. I probably explained that terribly. Which is why I'm so very glad to loop this bit around back to the beginning and say Bitluni's video explains this really rather well. I saw the video and he either doesn't actually mention the name of it or I just passed me by, but I am almost certain that the next time I am going to be trying to dim an LED, rather than just use some basic PWM or a library, I'm going to give this a go, because this just seems like a really interesting and very efficient way to set up LED dimming without having to actually go through the normal motions of using PWM. So as I mentioned in the introduction, we have an interview with Kevin Cappucio, the creator of Jumperless, on this week's show. We got together to have a very quick chat about the newest iteration of Jumperless, which is called Jumperless version 5. But just before we get to that, let's very quickly go through the history of this. The original Jumperless showed up on the Electromaker project page, and I knew nothing about it, but just thought this is an awesome idea. A breadboard that takes away the need for jumper cables, allows you to use software to designate exactly how your circuit will work. You just put your components on the board, and then you put in software what you want it to do, and the LEDs give you feedback as to how your circuit is connected together. It also allowed you to probe the circuit at various different points from software once again, and had an Arduino Nano compatible header, but that's for any board that's Arduino Nano compatible, because the voltage can be changed on the fly on the board as well, so you don't have to worry about frying a microcontroller as long as you've set everything up all right. Which brings us on to version 5. Now, this is functionally Jumperless 2.0, really. The first Jumperless had several hardware revisions, I'm presuming 4, because that brings us up to version 5. And Kevin thought it would just be a cleaner break, which he may or may not mention in the interview. I had to edit it down a little bit to make it fit into the show. And this adds a bunch more functionality. All the same things, all the analog crossover switches underneath allow you to attach any point to any point on the board. The two rails can be plus or minus 8 volts or anything in between. You can set both rails to have custom different voltages if you want. And because of the way that the board works, you can connect or probe any point under the board using multiplexing, because the thing runs at quite a high rate as well. And as I may or may not have already mentioned, it's one of the first things I've seen that uses the RP2350B, one of the new variants of the new Raspberry Pi Silicon. This one just has a bunch more GPIO, which is of course a very useful thing for most projects. Anyway, I don't want to make this introduction super long, so if there's anything that isn't clear from me talking about Jumperless here or the interview itself, please do leave it as a comment in the comments down here, and either I will try and answer it myself, or I can directly ask Kevin, because yeah, I've been in touch with him on and off since I met him in Portland for Teardown. I somehow didn't manage to interview him when we were there because we were both busy doing our own things, but I'm sure he'd be happy to answer any questions about Jumperless. It is a passion project of his he's been working on for a very long time, and it's a very exciting thing that it's about to go live. Anyway, without any further ado, Kevin. So we talked about Jumperless on the Electromaker Show a long time ago when it first appeared, and feel free to tell me if this is a really bad way of describing it, but my initial idea when I saw Jumperless is like, oh, okay, someone saw a breadboard and thought we can do better than that, we can automate it, right?
Yeah.
So Jumperless itself is essentially like an automated breadboard. You can fill in the gaps of what I am not saying in a moment. But the cool thing is I spoke to Kevin via email at the time, and then I ended up going to Portland to Teardown, the amazing event that we covered, and there's a bunch of stuff on the channel of that if you haven't seen it yet. I will link anything we refer to here in the description of the video and all that kind of stuff. Where we met, and I did Kevin's workshop, which was very, very cool, which was adding a probe to a version 1 Jumperless. So I've obviously missed out a lot of stuff here, but where did the idea of Jumperless come from, and how, and from a high level view, sort of what have you put into it to make it what it is?
Yeah, I mean, I can't claim this idea. I feel like it's a really common idea, but everyone gets to a point where it's like, you start working it out, and then it's like, oh my God, this is going to take so much hardware to make this work. And I was just stupid enough to keep going. So yeah, it was 5 years ago. Just kind of was like, oh, that would be cool if that existed. And then I tried to find one that existed so I could just buy it, and did not exist. So, and
was here. Yeah, no, exactly. And in terms of what that thing is, I mean, we don't need to go into like the deepest technical specifications, but where Jumperless differs from, say, a regular breadboard is like, say you put some kind of an IC on there, like a motor controller IC or something, and then you wanted to connect it out in various ways. Traditionally, you'd get a bunch of jumper cables, and you'd go from pin to pin, and you'd have to do it all correctly. What is it about Jumperless that does away with these jumpers? What makes it jumperless?
Yeah, so I found this amazing chip. It's an analog crossbar switch. So crossbar switches come from back in the telephony days. They literally had a bunch of metal bars crossing each other, and how you would make a phone connection from one person to another, you would get a clip and you'd clip one bar to the next, and it allows you to connect anything. So they only make them in 8x16, so it needs 12 of them to cover a half-size breadboard. So yeah, that's what it does. It just, I want to connect there to there. It finds the chip that's connected to that point and finds a path and then connects it to there.
Cool. And of course, the idea being that pulls away the jumper cables completely. But the other thing as well is, if you take a cursory look at the Jumperless board, and obviously you've put up a bunch of updates about it as well, there's a visual indication there as well. So am I right in thinking there's an LED behind every hole, or is it every line?
Every hole. On the new one, it's every hole. Yeah.
That's crazy. Yeah.
It's 451 LEDs on this thing.
Yeah.
And that's what I found with the original Jumperless. There was one just for each row, which works. But, when everything's hidden behind on the backside, if it's not telling you what's going on, it's not as easy to work with it. Like the user feedback is huge on these. So that's why I needed 500 LEDs now, because I think it makes it feel more like you're using real wires.
For sure, yeah. And if someone was to sort of look at Jumperless for the first time, which I can't exactly do, obviously, because I sort of know the project, but if someone was to look at it for the first time, obviously you've got, the breadboard, and once you've got your head around the idea that you can put components onto the breadboard and match them up any way that you want to, there's also headers for Arduino Nano compatible boards, right? Does it have to be the OG 5 volt tolerant one, or could you put other ones in?
I picked the Arduino Nano just because it's probably the one footprint that you can get just about any board in. You can get STM32s, like it's as close to a standard as they have.
Sure, yeah.
But yeah, so no, it doesn't need to be a Nano.
Cool. So the idea is you can plug, your development board into the top of the Jumperless board, but the thing itself can be plugged straight into the browser and controlled from there. So if someone wanted to just test some circuitry and they had literally Jumperless components and a USB cable, they'd be able to set that all up using what I always get this wrong. Is it called Wokwi or Wowki?
Oh, now you're making me question it.
It's
Wokwi, I think.
Yeah. That's right. It is Wokwi. Yeah, I don't think I've ever pronounced that correctly on the show. And I'll link this in the description, and maybe after we've talked, I can show this in the show. Wokwi is an amazing browser-based simulator and code generator. It can do multiple things. So you've got Jumperless, which is the Jumperless board. You've got Wokwi as a way of controlling it, or you can add a nano footprint board to it. So what? As well as not having to use jumper cables, what's the benefit of having all of these different switches in different places? For example, if you have components going through a part of your circuit and you want to do power profiling of that part of your circuit, what are the options there?
So once you can connect anything to anything, you can connect all your ADCs. So the new one has 7 channels of measurement, and then I have current sensors. And there's 10 GPIO, so you can just the Jumperless itself can kind of act like your dev board. And so what you can do is you can just set it to show the voltage on any point as a color. So, you can do anything you want with it, but having that measurement in it is really cool. So you can.
Yeah, for sure. Yeah. I mean, I think that's the dream for a lot of folks, isn't it? Because I my need to really drill down into the power of my project use has been not much in the past. I went down the rabbit hole. I think most people do once you've used Arduinos for a while, of like trying to get the lowest possible draw out of one, and you follow the forum posts that say take this resistor off, take the LED, all that stuff. But the utility of being able to have current and voltage sensing at various points and just software define it essentially is something that I think is a lot of folks will find awesome. But the reason that I very last minute kind of said, hey, can we jump on a call and talk, is because by the time this interview goes out, Jumperless version 5 should have started its funding cycle on crowd supply. Now, if that's not the case and it hasn't gone live, it's obviously this interview will still go out. I'll be talking about the live page in the next show. But there's a mild elephant in the room there, is that the Jumperless that I know and the one that I have is version 1. And the next version that you're releasing is version 5. So how did we get to the 5th iteration as your second release? I
imagine the sentence, oh no, you have a version 1 revision 4. But what you're thinking of is a version 2 revision 1. I figured I had 4 hardware revisions during making the original Jumperless. And so, I just took the last hardware revision and was like, I'm just going to sidestep all of those problems of knowing what revision I'm dealing with and just put it at the end, V5, no confusion anymore.
Yeah, so it sounds fine. It sounds like a good way of doing things.
And it kind of sounds cool. I don't know.
Yeah. No, it's cool. Yeah, absolutely. But but in terms of all of these revisions, I mean, obviously some of this stuff will be incremental. Some of this will be design decisions that you took and then maybe changed later. But from a broad standpoint, what is it about the Jumperless version 5 that makes it such a step up from the original one that you released?
So the original Jumperless, that probe thing that you did the workshop for, that was not even a glimmer in my eye when I actually made the hardware. That was a pure hack. I found some GPIO on the top corner and then figured out how to do it.
Right. Okay.
But the downside of that is it has to disconnect everything, and it's seriously connecting each row to a measurement channel, and it's looking for a PWM signal coming off this. It just has a lot of limits of how well probing can work. Like if two things are connected on the board, doesn't know which one it is. So you have to click through it and like decide which one you actually meant to click.
Yeah.
So by having the probe separate, it makes it just, as soon as I made the probe for the original Jumperless, I was like, oh, this is how this should be used.
Yeah.
And so I decided to just redo the whole thing with the probing first, because it just makes it so much nicer to use. It's just pleasurable.
I suppose one thing that might be worth just very quickly going over, just again for people who may be hearing about Jumperless for the first time. What does the probe do? Like what was the idea for having the probe initially, and again, kind of what functionality do you see it bringing to people when they have the probe alongside what it can already do?
I mean, the whole point of all of it is getting a circuit from your brain into a board as if you're just thinking it onto a board. And it still works with Walkwe, but like that's still another step. Like you need to look up at a computer and set up your circuit there and then look down at your circuit. And with the probe, it like keeps you just zoned into your circuit, right? Yeah. That's really, it's just being intuitive. And then it also can be a routable measurement channel. So if you flip the switch to measure, it is now just like any other connection on the breadboard, but by default, it measures voltage. But you could be like, okay, I want to see what happens if I connect, this pin to everything on the board. You can just put it at the end of your probe and just touch everything.
Sure, yeah.
It makes it just, I don't know, it's hard to explain. It feels good.
So we made a quick cut because we thought a visual aid would actually be better than the two of us trying to describe something that is visual. So Kevin, you now have your overhead camera on and a couple of components, an LED and a resistor on the Jumperless, and there's some LEDs already lit up there. So what's going on here? What am I looking at?
So I just clicked 2 random rows, but this pink and blue, these would be connected by a jumper. But it's not showing anything because they're not connected in the right spot. So yeah, with the probe, I can just put down connections and instead of trying to go between a computer and your actual circuit, you can just sit there and poke stuff out, and it gives you really nice feedback to immediately be able to just put something together.
For sure, yeah. And the resolution of the video is pretty good, but just to be clear about it, once you made those connections, you can designate which of the rails is... Oh no, I see there's a positive and a negative rail there. You select which is positive and which is ground after the fact, right?
Yeah, so these 2 rails, the top and bottom positive rail, are actually separate. So I can go through and change the voltage on, let's say, just the top. And I can just say, oh, I want it at 3 volts. And then see the LED is a bit dimmer. Yeah. But yeah, so they're each one. So yeah, that matters. Ground is always ground. Just because it's always important to have a solid connection to ground. But yeah, so I could, if I wanted to connect to the bottom rail, now it's bright again. So those are 2 separate rails.
Yeah, okay, cool.
And
sorry, go on. Yeah.
And stuff, you can have plus minus 8 volt supplies. So these rails go plus minus 8 volts.
Nice.
Yeah. That's
going to be really handy for the Eurorack module creation crowd.
Yeah.
And the one other thing is just you mentioned that you get measurements just on board on the probe now, right?
Oh yes. So I mean, I can do it in measurement mode, and it is measuring the voltage at any given point.
That's so cool that it just shows up on the screen.
Yeah. Let's see what that rail's at. That was too much. And the probe lets you do, like, I don't know, eventually it will be the inputs for Doom.
Yeah, because you got to get Doom running on it. Absolutely. Yeah. So yeah, that very brief demo is awesome, and I can already tell that what we need to do at some point is do like a proper, like, longer version of this where we can go through a bunch of stuff. Maybe I'll have my version 1 set up here as well, and we can, do some cross-internet hacking of some description, and then you can find out truly how terrible electronics actually are. But one other thing just before we do wrap up here, Jumperless, the version 5 is quite interesting because am I right in thinking it's one of the first pieces of hardware that's running on the RP2350?
Yeah. I mean, 2350B, you don't see those. Those are even more unlikely.
Is that the one with the bigger footprint, like the more GPIO and stuff? Cool.
Yeah. So it saved me a GPIO expander, first of all, which is great. But yeah, so when it debuted at DEF CON, I was there. When I got my ticket, I saw the RP2350 and I was like, oh my, I ran home and redesigned. I missed most of DEF CON just because it just launched and I was like, oh my God, Jumperless needs this. And so, yeah, it's been redesigned with the RP2350B and it's way better now. I mean, it being more powerful lets me run a Python interpreter now, which before I wouldn't kind of have room for it. But yeah, so.
Yeah, amazing. Well, I mean, I'm kind of excited about Jumperless version 5. I was excited about the first one before I knew you at all. I remember you dropping me an email saying how happy you were that I covered it, how enthusiastic I was about it, and I'm really into this one as well. I will, of course, be linking the crowd supply page under here and trying to arrange a slightly longer version of this with you at some point. But by the time folks see this video, it will almost certainly have launched on Crowd Supply, so head to the link underneath. You can go and find it. But yeah, Kevin, thank you very much for making time at such short notice to chat to me about this. I hope the launch goes really well. Look forward to chatting to you again soon.
Cool. Thanks, Ian. Thanks for having me on.
So that was Kevin, and this is Jumperless version 5. I hope that this has given you a taste as to why I personally am so excited about the Jumperless project. Jumperless is something that I am behind. I'm always very happy to cover it on the Electromaker Show, but the main reason I'm behind it is just because I originally loved the first Jumperless, and I really love what Kevin has done with it since. He's really trying to foster a community around a genuinely good tool and something that is nice to use, and there is now community projects around it. So there is a command line tool, for example, for it in a GUI. I will leave it at that for now. The link will be in the description. I highly suggest going and taking a look at it, because yeah, this is still one of the projects that I'm personally the most excited about, and I'm really interested to hear what you, as the Electromaker community, think of it. And as I think I mentioned before the video, if you have any questions or anything about it, please do leave them in the comments of this video, because I could pass them directly on to Kevin so you can get an answer from the creator himself. Before moving on, it is time to announce the winner of our Texas Instruments MSP M0C1104 Launchpad Development Kit giveaway. Now, that was quite a long sentence, but the reason there's such a long designation number on that part is because Texas Instruments have a long history of putting out very affordable, very low power usage parts for pretty much anything you would want to make. And this one is no different whatsoever. In fact, I would say that with the built-in ARM Cortex M0 Plus, it's going to be an incredibly capable chip, but that is following that tradition of Texas Instruments being very trustworthy and pretty much the name in low power MCUs. Anyway, we've talked about it enough in the recent weeks on the show. You can head back and watch the actual product of the week video, which will be linked in the description here. But right now we have a winner, and the winner of the Launchpad competition was Bert Brecht 7540 with the hashtag Launchpad. I would like to point out that everyone that put the hashtag Launchpad or Texas Instruments was entered into this. There was a couple of crossed wires here at Electromaker Towers, and there were 2 different hashtags for this contest, but they were all taken account of. Now, yeah, Bert Brecht's comment was, I would like to make a child programmable robot kit that sells for under $20. The low-cost MCU makes this possible. And that is a really wonderful idea. I really hope that that does come to fruition, and when you are putting that together, when you have that project put together, please do put it on the Electromaker project page, because in the process of coming up with a product like that, you're of course going to come up with a lot of wonderful project stuff as well. And if you're willing to share those ideas, I'm sure everyone would love to see them. But yes, congratulations. We'll be in touch with you as to how you can get that out to you. But in this show, we also have another product of the week, and therefore another opportunity to win, and that is coming up. Now, Raspberry Pi has released a VS Code extension exclusively for working with the Raspberry Pi Pico. However, it's probably not going to be exclusive for long. It currently works with the Pico W, and the Pico 2, and it will be Pico 2W when that appears. I would imagine, however, that support for other RP2040 and RP2350 boards will be added soon. Now, there is a blog post about this. I will be linking the blog post in the description. It's definitely worth having a read through because it tells you exactly what the extension is and how to get started with it. However, the majority of what is in this article, I just thought, you know what, I have a Pi Pico 2 here on my desk that I haven't really had much time to play with yet. Let's just see how easy it is to spool up a project. And the answer is really quite simple indeed. If you open up VS Code, head to the Extensions tab and just search for Pico, install it, and then reload VS Code. I needed to in order to see the Pico tab on the side. You'll also notice there's a compile and a run button down here, and the Pico SDK number down here. I have the board Pico 2 already selected because I've been messing around with this before, but let's pretend that I hadn't been. So in this side panel here, I have my Pico 2 down here, and I would like to do something with it. So I'm going to say new project from example. The first thing I usually do when I get a new board like this is open an example Blinky code. So let's have a look, select the example name, Blink. Excellent. The board I have is a Pico 2. Right now Pico and Pico W are the only other supported ones. I imagine that will change. And just for fun, let's make this a RISC-V project. Now, as you'll see, I have a number of different folders that have not been very well named here. I'm just going to call this Blink Show because it is for the show. Pico SDK version 2.0, that's what I'm happy to work with. Now, I don't actually have my debugger, unfortunately. I have a separate Pi Pico, which is exactly like this one, but with things plugged into it, which acts as my Raspberry Pi debugger. The actual debugger itself is fantastic, and I should just get one because they're so cheap and so easy, and they've got their own case. But yeah, I have a mess of wires attached to a Pico that I use as my debugger, and I don't have that for today, so we'll skip it. But I'm just going to click Create. And some of it will happen faster for me because I did try this once before, but essentially it downloads the SDK, sets up the project for you, and opens a brand new VS Code instance. That's the word I was looking for. And within this instance, I can open my Blink C code, and here it is. It's probably a little bit small for you. I'll make it bigger. But here's something that I really, really love. Before we go into actually running, compiling and uploading this to the board or anything like that, in fact, thinking about it, I'm going to go ahead and take my board out, hold the boot select button down, and plug it in again so it's ready to take code. But if you, this is the Blink stuff here, and I like it, and I just want to, for now, get some Blink going. But in the future, I'd maybe like to mess around and turn this into a pulsing, waving PWM type of affair. Well, I can just click on the same tab, and the documentation for the hardware APIs and the high-level APIs are all just here on the side. So if I click Hardware API, it opens here in Visual Studio Code. If I search for PWM, there is my hardware PWM documentation. Yeah, I don't think I need to go into any more detail as to why that is cool. So we'll get rid of that for now. We'll click Compile, which will open up the terminal inside VS Code. Again, this is following with the theme that everything you need is here, and it will do the compilation. And I'm going to click Run. And now here we have a blinking LED on a Raspberry Pi Pico 2. In fact, I should probably just make a little film of that so I can show you it, so I can prove that I made an LED blink. So I'm absolutely aware that was a breakneck whistle stop tour of the very basics you can do with the Pico extension. I wanted to put it in the show, even though that was a bit mad and fast, because I just think they've genuinely done a really good job on it. I'm going to mess around with the actual debugging side of things, and I might do a little bit more about this in the future. I feel like a standalone video from Electromaker about this might be something that people would be interested in. Please do let me know in the comments if you'd like to see me have a run through of this. But I'm going to leave it at that for now. I will leave a link to this in the description of the video. In case it wasn't clear, I just literally followed this blog post, and it tells you step by step what you need to do. I already had a few things installed, but other than that, that was it. I followed the steps here, got as far as blinking an LED using RISC-V compilation, and went cool, and then noticed that the hardware API was built into it and went cool. It is time to talk about our product of the week, and this time it is the Arduino Alvik. Now, this is Arduino's robotics kit. It is an all-in-one robot filled with sensors, and it has a battery in it, and it has an ESP32-based Arduino Nano on the top. But the Arduino Nano is just talking to the robot itself. The robot has its own custom STM32-based board inside it, which means the possibilities for interacting with it are very wide. So from my perspective, Robin's video takes you through everything, but there's a few things that I find super interesting, some of which are just obvious features of the Alvik, and some of which take a little extra step of thinking about, but it was the thing that really got to me when I actually watched Robin's video through and thought about what I would do with the Alvik if I was in a position of, say, being an educator, working with various different ranges of students at different levels. So before we get onto that, the box itself has a bunch of different things in it that will be useful. All the obvious stuff you'd expect for a robot, like motors, and there's a battery, and there's various kinds of sensors on board as well. Things like time of flight sensors, distance sensors, line following array sensors on the bottom, color sensors, and I'm probably forgetting a few. I'm just going off the top of my head here. But the box itself also comes with an array of different solderless connections. So stemmer / quick, the Arduino, the Adafruit and Sparkfun modules that don't need any soldering can connect to it. Same with the Grove sensors from Seed Studio, which means that you can come up with a very custom design for a robot quite early. And while I believe it's still in beta and maybe it isn't out fully yet, there is the option of block-based programming with this robot, which means that you could start a class with something that is block-based. You add blocks to it and it gets the robot to do whatever it does. And then block-based programming into MicroPython is a very good way into learning programming, because block-based teaches you all of the logic and the program flow, and then it's just learning syntax. And while I'm one of the people that finds Python indenting somewhat a little bit maddening, it's undoubtedly probably the easiest programming language to learn. Feel free to tell me why I am wrong in the comment section below. And as you might expect, there are a huge amount of learning materials about the Alvik available from Arduino. On the main Alvik page, I just clicked through to the lessons, and after signing into my Arduino account, there's this huge amount of free content that covers everything from just getting set up and going, right through to different kinds of automation. This is one based on color, for example, using the onboard color sensor, trigger actions using data from the RGB color sensor, things like that. Program Alvik to intelligently respond to your hand movements. So that's some gesture-based stuff as well. Each one of these things takes you through everything you need to set up, both physically and in the Arduino MicroPython Lab, I believe is what they call their IDE version that's spooled up specifically for MicroPython. There's even a PDF of a general curriculum for different chunks you can do to go through. So there's already a wide range of potential people that could use just one Alvik kit. If you're working, say, in a school environment with kids over multiple years, then the Alvik could work everything from the earliest age you could potentially get into block-based programming right through to people learning the Arduino IDE and Arduino code. But with a little bit of imagination, you could imagine those things extending outwards as well. University students could be tasked with writing their own driver. At the end of the day, the STM32 coprocessor is just controlling everything that happens on the robots, and the ESP32 is talking to it via the Alvik library. Take that library away, and you have a very complex programming task to get the ESP32 to talk to the STM32 and get the robots to do, well, anything. And at the other end of the scale, there are robots that will go from grid spot to grid spot on a mat, and they don't have much in the way of sensors on board. They just have buttons on top that remember your presses. My partner works in early years education, and we've had one of these at home, and they're really cool, little hardy robots. And if you press forwards on the robot 5 times, turn once, and then forward twice again, it'll go forward 5 units, 5 squares, turn, and then go forward 2 squares. What an interesting thing it would be to set your top level students the task of making a library that is a driver for the Alvik, your mid-level students to create in MicroPython something that allows the robot to move when pressed on the buttons, like I previously said. You could even maybe set that to the people who are learning block-based programming as a way of learning program control flow. And then the people who are not ready in any way to actually start working with the digital side of things could still end up with a robot that they can press a number of times and see the reaction. What they put in is what comes out. That's quite a wide range of potential use cases. Now, I understand that was a bit of a rant on my part. That's my job here, is to be enthusiastic and think about things slightly differently. Robin can give you the more down-to-earth actual run-through of everything that the Alvik is and that it does. But having waffled a little bit, I think you're all probably waiting for the moment where I say, here's where you can win an Alvik, so here's where you can win an Arduino Alvik. So, as previously mentioned in the last 2 competitions, we've changed it up ever so slightly. Instead of entering under this video, I'd like you to enter under the Product of the Week video that I've just been talking about. It is linked in the description of this video as well. I'll be posting it all over social media in the coming days as well. So underneath this video, all you need to do is make sure that you are subscribed to our YouTube channel, and then leave a comment saying what you would make if you won an Arduino Alvik, and leave the hashtag Alvik, ALVIK, all one word, Alvik. And in a couple of weeks, I will be gathering all of those entries together and choosing a winner at random. And I'm really excited to hear the ideas that you have for the Alvik, because as I just said, my admittedly slightly pie-in-the-sky idea for it was really quite wide. And that's what the thing I love about robotics kits like this. There are many that if you really get into the weeds, you can get them to do whatever you want. But this is one where the margins at each side are so wide, given the stuff that Arduino has already given you. You could get a huge amount of utility out of one of these robots without actually having to go into the weeds yourself and come up with new ideas. But the ideas are there. And I feel like someone who was an educator with a little bit more idea as to what might work than me could come up with even better ideas than I just spooled off the top of my head, probably quite annoyingly for some of you. But yes, that competition will be brought back in a couple of weeks, where we will be announcing the winner. So, good luck. That has been our show for this week. Thank you so much for joining me, and thank you for your continued support. As always, clicking like and subscribe and leaving a comment on this video does a lot to help us on the YouTube end of things, but the real way that you can help Electromaker continue doing what it's doing is by heading to the Electromaker store at www.electromaker.io/shop. We stock pretty much everything from everyone, and if you buy it from us, that helps this show financially and directly. Just a quick reminder, we do not put any monetization on our YouTube videos or our podcast. This is just the way that we do things. I'm really interested to hear what you thought of this week's show and the interview with Kevin, and the general content that I'm covering on the show as is. I'm always looking at ways to improve this and maybe tweak the content so that it appeals to a wider part of the audience. Just please do let me know in the comments or in our Discord server. You can find a link to that in the description here, along with links to everything we talked about this week. So I'll be back to talk to you soon, but for now I hope you have a fun, safe and creative week. Take care.